minutes is of course the commercial part of this free seminar, the master class in quality management and a master course in quality management, which starts on the 20th of May. Very nice online, by the way, online sessions 4 times, and you will learn a lot about quality management that goes way beyond ISO 9000, Robert, way beyond. So that's interesting too. We will share the link and we will update you on all the information. If you'd like to know more, you can also go to our YouTube channel. On our YouTube channel, you'll find more recordings of both Bill and I on webinars in quality management, as well on lean manufacturing with my colleagues like Stefan and Martin and Boudewijn. So we try to share as much as we can for you all to get the knowledge around. So far so good. For this afternoon, we have the next program organized. First of all, we'd like to talk with you about the present economics. As we know, we're struggling in our economy. Companies have to perform. Companies need to reduce costs, and we have severe competition throughout the world, both from Asia and from the United States. And what we learn in our consultancy business, that this is a continuous struggle. Companies are sometimes not well organized, sometimes they struggle with how to approach customers and what kind of methodologies. Well, there's a very interesting methodology that will be presented by Bill. It's called the Taguchi Loss Function, and it might help you very well in your organizations to see how you can optimize processes and with that reduce failure cost and so on and so forth, as well as get a better customer orientation in your organization. Bill gets 45 minutes for that. For those who know Bill a little bit, it will never be 45 minutes. If I give him 45 minutes, it becomes an hour. If I give him an hour, it becomes 2 hours. If I give him 2 hours, it becomes 4 hours. So we'll see what happens tonight. As long as it is interesting, we will continue. Then we have a break, especially for the people online. You can go away from your screen. Then we will have a break. After the break, we'll have a talk about systems. The new ISO 9000 is to be launched in something around September, October probably. We have a preview and we'll share with you what's in there. We already had the table here. We had a little discussion how valuable is ISO 9000 and is it a hate or nightmare or is it a blessing? We can discuss that. And then after the next break, we have a kind of free workshop where we can just interact with each other and share experiences regarding how you use AI in combination with quality management. We have an example for ourselves, but it's really nice if you share with us as well how you work with AI and how it supports quality management, or maybe not. So that's open for discussion.
Especially this content could take a while to absorb. It doesn't come. As I find it with people, they'll say, "Oh no, it's beginning to make sense." So I take into account that that some of this is take some time. All right. So the title Taguchi's Loss Function, and there's a big. It's all about economics, and as Jeroen was talking earlier about economics, I think the least challenging part of economics and ideas about quality is the idea of organizations operating with a sense of teamwork, and teamwork being working together. And so I'll ask audiences, are they familiar with the concept of synergy? And people have heard of the word synergy. And I'll say, well, give me an example of synergy. And they'll say, the whole is more than the sum of the parts. And I say, okay. And that's like 2 people being as productive as 3 is positive synergy, or as productive as 4 is positive synergy, or 5 or 6. But in order to have positive synergy, you have to have an understanding of relationships. And the challenge is organizations do not have a sense of relationships, which means what organizations will do on their best day is have two people as productive as two. But they can't quite do that. And that's because there are relationships in the organization which are ignored. They can't even get to two. So they would struggle to get to two. And very likely may have negative synergy, which is 1 + 1 is 1 or -1. And so Taguchi's ideas are very much in keeping with positive synergy. And I look at it as, what organization is not interested in positive synergy? But another thing to take into account is is the idea that the proposal is, instead of thinking that profit is the reason for companies to be in business, what if we shifted to profit is the result of how companies work together? So it's not that profit is not important, it's a question of, is it profit first? Is profit the goal, or is profit the result? And in most organizations, profit is the goal, they don't think of it as the result. And you'll see how that ties in. So while counting from the number of employees to the number of products shipped is quantity-based, right? And quantity-based is, about these blue pens, 1 pen and 1 pen is 2 pens. That's quantity-based. Quantity-based is zero synergy. It's just looking at things in isolation and saying, 1 cup plus another cup is 2 cups. That's quantity-based. And organizations treat quality with a quantity mindset. A quantity mindset is when you look at things in isolation without relationships. That's zero synergy. So the difference is, okay, I'll go back to, while counting from the number of employees to the number of products shipped last quarter is quantity-based, the differences between entities counted is quality-based with a focus on use, and I'll clarify that. For an aircraft manufacturer, if the parts of an airplane remained in boxes and were never assembled, then the variation in each part, as well as the variation in employees, would be very hard to discern. And what I'm talking about there is that if I take these blue pens and take them all apart, and I look at all the caps as being the same without variation, and all the bodies as being the same without variation, that's how organizations operate. They treat a cap as a cap, a body as a body, an engineer as an engineer, a cup as a cup, a computer as a computer, and don't see the people as different. They're all a bunch of interchangeable parts. Go get me another manufacturing engineer. Go get me another whatever. The company I worked for in Los Angeles for 26 years, Rocketdyne, we made rocket engines. And for 9 years, Rocketdyne was owned by Boeing. And so when I would do training, 1 day extensive training within the commercial airplane business, I say to them, do the parts of a 787 fly in close formation? And they say no. I say, well, but that's how we manage them. We manage them as if they're separate. And what we're going to look at today is what Dr. Taguchi is talking about is not looking at the parts in isolation, but looking at how the parts come together, which is a positive synergy. It's a relationship thing, which means it's a positive synergy thing. So variation, if you understand that, then you see that variation appears in how the parts are integrated and how the system performs. Okay. So there's an intro, then compliance, excellence, contextual excellence, and then close. So this is me with Dr. Taguchi. I met him in '87. This photo is, I think his 80th birthday, which would have been 2004. Okay. And this is me with Dr. Deming in 1990. He's the guy in the chair sitting down. And with Russell Lakoff, we'll also talk about, I met Russ in 2003. Russ was a professor of systems theory at the University of Pennsylvania for many years. So I spent a lot of time with him, a lot of time with Taguchi, and just a few hours with Dr. Deming, not very much. When Deming would do seminars, and even in his last book, he'd say, are you in favor of improvement of quality? And he would joke and he'd say, we can do a national referendum. And even called it, he said, we can have a secret ballot. Everybody's in favor of quality. I mean, so what's going on here is everybody's in favor of improvement of quality. What's missing is, what does quality mean? Okay. So there's compliance excellence, which is one form of quality. It's the dominant mode of quality. So when Deming said they are in favor of quality, well, what's quality? The traditional definition of quality, and I've not seen many organizations that don't do anything much different than this. Quality is defined as conformance to a set of requirements. So it's looking at the cap of the pen and saying, it's good because the requirements are met, and if they're not met, it's bad. It's either one or the other, one or the other. And the body, one or the other, one or the other. And in that simple example, we're looking at these in isolation, because what we're not looking at is how well the cap fits onto the bottle. As if it doesn't, as if the cap is good and the body is good, then it will fit. That's the model. And we're going to look at, not only is that the model, we're going to look at is what's missing in that model. But that is, in my experience, the dominant model everywhere. And I've done seminars like this in New Zealand, online, live. It's all the same. We're all stuck in the same boat. Zero defects is alive and well. The idea that we're striving for everything being good. The challenge is, in a world of good parts and bad parts where we strive for good, better doesn't exist. So when Deming talked about improvement of quality, as long as we're in the world of compliance excellence, looking at parts in isolation, we don't know how to create better because we're stuck at good. And then what happens within organizations, because we're stuck at good, is that we don't work on the good because there's nothing to do. So what we do is we wait for bad to happen. And then we're surprised when bad happens. And so when I was explaining these ideas to a group of Boeing commercial airplane people, my question to them was, how much time do you spend every day discussing parts that are good that arrive on time? And they said, none. I said, well, why is that? And the answer was, well, if it's not broken, don't fix it. I said, what if you drove your car without thinking? When would you put gas in the car? When it runs out. When would you call the doctor? When you're sick? When would you call the plumber? So what you end up with is, in a compliance excellence model, looking at parts in isolation, we're creating bad because we don't focus on anything until it's bad. So we wait, we're hoping it's good, and if it's good, we keep doing what we're doing, but we don't see bad coming. So it's like saying, does the car have gas? Yes. Does the car have gas? Yes. Does the car have gas? No. And that happens like that. So we go from it's good to it's bad, and then we're surprised. And I spent a whole lot of time working with people. They called me when it was bad. They rarely called me when it was good, because it doesn't make sense to call me when it's good. But if you shifted the thinking from compliance excellence to contextual excellence, and shifted the question from is it good to how good, does the car have gas, to how much gas, that offers dramatic improvements of quality and synergy. All right. So the model I see in organizations is we follow a bunch of steps to complete a task. And that's not just manufacturing. This could be software. In any organization, we follow steps. Something is good. Task B is good. And then we take those tasks and they flow forward And here in this simple model, I say, well, let's pretend that A and B come together to create subcomponent 1, others into subcomponent 2, and then there's progressive levels of integration until you get the whole thing. And in this compliance excellence model, we can only pass on what is good, because if I passed on to Jeroen something which is bad, he'd be angry with me, so I have to pass on what is good. But this compliance excellence model, where all these words in yellow are binary, it's good or it's bad, it's good or it's bad. How can you have improvement in a binary world? What you end up with, the improvement is to go from bad to good and then wait for bad to happen. That's where most organizations are. All right, so an exercise I've been using for a good 30 years is imagine you're employed as a senior buyer in the procurement and a purchasing department of an organization, and your company designs and assembles, and your job is to go off and buy these tubes, a bunch of short metal tubes in one of the products. And the scenario is, this is highly idealized. Somebody's joining. All right. So in this highly idealized situation, where each of you has the job of being a procurement specialist, just buying tubes for this one product that we make, I say, imagine we go to 4 suppliers and we give them the requirements we want for the tubes. And imagine all 4 suppliers come back and say, all the tubes are the same price, £1 each, €1 each, whatever it is. Imagine they all guarantee the same delivery schedule. Imagine all of them guarantee that the outer diameter, which is the only thing we really care about, meets requirements and is defect-free all the time. Okay. Who'd you buy from? And so I ask this question every year to a graduate class in quality management. This is also in our online master course. And the majority of people would say it doesn't matter. So the other option is, do you buy from 1, 2, 3, or 4? People say, no, it doesn't matter. They're all the same. I said, okay. Hold that thought. So let's move ahead to contextual excellence. So we have the model I just shared with you. So I say, what's missing in the model? What's missing is everything in this model in yellow is binary. It's good or it's bad. It's good or it's bad. There's no degrees of good in this model. Degrees of good would be a different model and offers advantages. It's not to say this we shouldn't use this model. Right now we default to this model as if it's the only way to go. The proposal is we use this model when it makes sense, and we look at good and replace it with degrees of good, and fit with degrees of fit, and works with degrees of work, if we're striving for improvement. So use the model that makes sense. So this is not to say everything needs to be improved. It just says this model has a place. So I'm not throwing the model out. I'm just saying this model has weaknesses, but this model has given us everything we have. So let's be thankful. But what's missing is it's causing our organizations to be highly reactive and not focused on improvement. So if your organization never wants to improve, then keep using this model. Pray that your competitors keep using this model too. That's how you stay in business. So Dr. Deming and Russ Agoff got together in 1992 for 3-4 hours, and it got condensed to a 30-minute video. And in there, Russ says the characteristic way of management, again, he's a business professor. He said the characteristic way of management, take a complex system, divide it into parts, manage each part as well as possible. And if that's done, and so, in a longer course, I would ask people, well, how would you complete the sentence? And then we look at how Russ would complete it. And Russ said, we'll behave well. Then he said, that's absolutely false. Well, the will behave well is the model I just showed you of the good and the bad. That's the model we're using. Again, there's a place for it. A system is not the sum of its parts. Right? The sum of its parts would be addition, which is zero synergy. right? The parts of the plane are separate, right? They have to come together, and that's what gives the interactions that causes flight. So the art of managing interactions, which is not to look at the actions separately, the parts separately, but how they connect to each other, is much different. And focusing on interactions, well, focusing on actions is everyone saying, my part is good, my part is good, my part is good, my part is good, without looking at how my part relates to your part. So there could be a requirement that Jeroen and I have to be 10 meters apart on a soccer or a football pitch, right? That's not my job, that's our job. And so the traditional model is, I give him a job, I take a job, and we each complete the requirements separately. Managing interactions is the idea that I can't complete my task without watching how he completes his task. That I can't order the wine without knowing the meal. I can't arrange the music for the wedding without knowing the guest list. The idea is in our personal lives, that's what we do. We manage interactions. Managing interactions is the key to positive synergy. That you arrange the hotel to be in line with the rental car and the airplane reservations. So we already manage interactions. We just don't think of it that way. So go back to the tubes and add to this part two. What if all four suppliers provided more detailed information on the outer diameter results? And I'll show you what that looks like. And imagine I show you the requirements for the outer diameter. And so the red lines are the requirements, that the outer diameter of the tube has to be somewhere above the minimum, that's the LSL, and below the maximum. And then these histograms, 1, 2, 3, and 4, represent data from the suppliers to explain how the outer diameters of the tubes, if you buy from them, will behave. And the proposal is, not only are they equal price, equal schedule, guarantee zero defects, but what if I guarantee that if you buy from number 3, they'll always come from that distribution, the same average, the same location, likewise 1, 2, 3, or 4. Any is also an option. And what happens here is that people will select 4. So what's interesting is, even though people in most organizations are focusing on zero defects, all of a sudden, if I show the 4 distributions, it matters where they are located. And I found that fascinating because prior to that, the objective was to meet requirements. And if I tell you they meet requirements and it's guaranteed, then if I don't show the distributions, it doesn't matter. As soon as we show the distributions, it all of a sudden matters. And then people like number 4. And when I ask, why do you like 4? They say 4 is most consistent. And I say, to what? Well, to each other, which is still looking at those in isolation, which is the same thinking. It's a consistent line of thinking, looking at things in isolation. And this is a bowling ball. Inside that bag is my wife's bowling ball. We went bowling a particular night with the kids that got back from bowling. And after walking down the hallway, I asked my wife, why the bowling bag was in the doorway there. And she said, ask our son, who was about 13 or 14 at the time. And I asked him, I said, why'd you put the bag there? And he said, Mom said, put it in the bedroom. Which means he met requirements. So in today's organizations, this is good. And not only is it good, is that you cannot improve this. That's the mindset. But again, this mindset has given us most of what we have. All right, inspiration from Ford and Toyota. In the late 60s, Frank Pipp, an assembly plant manager at Ford, he instructed his team to buy competitors' cars, because at that point, within Ford, every time they put parts together on the assembly line, hammers were used to bang the parts together. Well, the idea is, the proposal is, well, actually what we found is the hammers are needed because no one was paying attention to the relationship between the parts. but they all met requirements. So if everyone's out there meeting requirements minimally, where does the impact show up? At assembly. So at Ford, banging it together was the norm. He bought competitors' cars. They assembled just like theirs. If they could be assembled without a mallet, they were known as snap fit. In Frank's experience, snap fit was rare to his amazement. They finally went off and bought a competitor's car. Instead of it assembling just like theirs, they found one that assembled without mallets. They were so astounded that he had them take the car apart again, put it together, never used mallets. It was 100% snap fit, the entire automobile. Turns out it was made by Toyota. And this is 1969. So in the late 60s, and there's good reason to believe, inspired by Dr. Taguchi, who worked with Toyota back in the 50s, that they were managing interactions and how the parts came together. And think of all the trouble they saved at assembly because the people who focus on the parts focus on how they come together.
Maybe, Bill, nice to add, maybe, the example of yesterday.
Yeah.
I will not mention the name, but we visited a production company that produces machines. We were overlooking the whole factory, and we heard bang, bang, bang.
Oh, yeah.
And that's all the sort of sounds that operators make while they are banging the things together. We literally heard the banging. Operators needed to weld pieces together, and it didn't work, so they bang it together in the right format so they can do the welding well, or they do the assembly well. So, and this first part of this seminar is about business economics. Well, where do you lose your money? Right there. The operator who is banging instead of being click and move on. And you might notice that in all of your organizations. I mean, it happens in our organization as well. It's quite a challenge to make it snap fit and to look for these relationships in between parts and to work together to make it economic viable, to put the parts together and move on. So I'd like to express that we as consultants from that part, we see all the inefficiency, and you can see it yourself as well. So it's not rocket science. Just walking to the factory, we saw also a man laying on the ground fixing things. Well, that's because the part
At the end of the assembly line.
At the end of the assembly line, precisely. That means that during the assembly something did not match well together. It didn't fit, and then the expert needs to come, mostly the most expensive guy in the whole organization, to fix things. And that's why this part is called economics of it, because the good and bad model, it means losing a lot of money. If you don't do the improvement, but you just wait it to be good, then fixing will follow.
Well, and to add what you're saying is, the traditional model is that we're banging them together because there are defects, that defects are allowed to be released. That somewhere along the line, somebody ships a defective part, and a defective part causes the hammer. What we're going to look at is, no, you can be within requirements and still need hammers. So good parts, so yeah, if you're out of spec, that will easily cause a hammer to be used. But what we're talking about is you can be in spec and still cause a hammer to be used.
Exactly.
So so we're watching this person spend I don't know if he was working before we got there, but easily an hour was being spent at final assembly trying to figure out why things didn't work, as opposed to just having it go through.
And on top of that,
yes,
you might recognize that in your own organization, this guy was thinking he was doing good work.
Of course.
Mm-hmm. He thinks that the hammer should be part of his toolkit because it's part of his work. Even worse, the manager provides the hammer.
Yes.
Because the manager thinks the hammer is required, get it fixed.
Yeah.
And that's where your costs go up.
That's exactly what you say. It's fixed. It's not resolved.
It's not resolved.
And then the challenge becomes, if this is caused by good parts going through this, I mean, if this is being caused by bad parts going through the system, well, then there's an inspection issue. But it's not clear in what we saw yesterday if the effort going on led to the discovery of, was it a bad part causing this or a bunch of good parts, which means it's just more than likely, this is just a way of doing business. And that's what's going on at the Ford factory. They're banging things together as if that's the only thing to do. And I've seen that in my experience. So again, I want to differentiate the bad parts causing the hammers, yes, but good parts will also cause hammers to be used. And I've seen plenty of that. And that's the blind spot. It's only the bad parts that cause that. No. Good parts cause that.
Perhaps, Bill, we're talking about assembly. You mentioned it is valid for every organization. So I happen to know in the audience there are people from research, from software development.
Yeah.
It's all the same. A software programmer programming something, it goes together with another program, it doesn't fit, we are going to fix it.
Yeah.
You do research, you don't talk with the research programmer and it doesn't fit. It's all the same.
Oh yeah, no, it's yeah, and what's behind this example here is, and I took a class from someone who studied with Dr. Deming, and what came out of it, it was very eye-opening. And the question I would ask, at a seminar of this produce in a supermarket is, if you were to go into a supermarket, the produce section, if I was to say to you, if all the fruits and vegetables in the supermarket are not bruised or otherwise physically damaged, would you expect people to sort through the oranges, sort through the apples? And maybe it might be 50-50. Actually, it's probably more than not people say, no, I would just take an apple, I'll just take an orange, I'll just take a watermelon. But then there's maybe 25% will say, yeah, I want that particular orange because it's a little juicier. And so when I ask them, why do you sort between them? The answer is because they're different. They're different ripenesses, different shapes. Well, the same scenario happens when you pull into a parking lot and you got all those parking spaces that meet requirements and you want the one closest to the door or the one under the tree. And so acceptability thinking is saying they're all the same, I'll take any parking spot. But as soon as you look at all the things that meet requirements and say, I want that professor, I want that parking spot, what you're doing is acknowledging that they're different, and the difference applies to your use of it. Okay? So the simple activity of sorting through fruit is an everyday reminder of how we look at things that meet requirements, and that's not good enough. In some situations, it may not be good enough. In some other situations, maybe it is. So are you in favor of quality, improvement of quality? Well, Dr. Deming defined quality differently than Phil Crosby. Right? Phil Crosby looks at quality and says that thing in isolation meets requirements, in isolation. Deming says a product or service possesses quality if it helps somebody. That's a relationship understanding of quality. So that's not me saying, the pass on the football, pitch to Jeroen was good. It's Jeroen telling me it was easier, it was hard or difficult. So that's not me providing it saying it's good, it's him receiving it saying it's good, or how good it is. Two different models of quality. So in the third part of this exercise, you go one step further. Again, I've been doing this for 30 years. What if I take everything I've given you so far and say the ideal value with that vertical dotted, dashed line, what if that's the ideal value? Does that change your choice? And so again, the scenario is all four are the same price, all four meet requirements. The distributions never change shape or location. They're used as is. and then I throw in the requirement and the ideal value. And going back to literally 30 some years ago, people with the ideal value, 75% of a class will take number 4. That's how dominant the thinking is about uniformity, but it's uniformity without respect for what's ideal. What Taguchi's talking about is an ideal value. What Taguchi's talking about is the closer we are to the ideal value, that orange, and I want an orange around that juiciness, and as it's a little more or a little less, then the use of it is not as valuable. And that's the blue curve. The blue curve is giving a sense of use of the thing based on the ideal value, right? And it's saying on the one hand, it could be a little high, a little low. There's a big impact, which could be big use of hammers, or it may be very shallow, in which case it doesn't matter if I'm, high, to the high side or the low side. But no matter what we're looking at with the blue curve is not the thing in isolation, but we're looking at is the use of it. And to turn this into an, let's see, we'll come back to that. So precision is making things consistent to each other, but it's got nothing to do with accuracy, which is being on the ideal value. Accuracy is focusing on the ideal value. So precision is uniformity without respect for what's ideal. Accuracy is focusing on the ideal. So acceptability is I'll take any of them. Desirability is when you say, I want that parking spot, I want that professor, I want that orange. And desirability is necessary for continual improvement of quality. Acceptability says they're all the same, it doesn't matter. The economics may not be worthwhile. So if you're landing an F-18 fighter plane on an aircraft carrier, then being close to the center is important that you don't go off into the structure, into the water. If you're landing the space shuttle at the Kennedy Space Center, you could be on the lower curve where you could be a lot off the center of the runway, no big deal. But still what we're looking at is the interaction between the airplane and where it lands. So imagine you're cutting a piece of wood to a desired length. And I would ask people, again, this is a 30-year-old question, how many lines do you draw across the top face before you make a cut? And people always say, I draw one line and then cut to the line. And when our son was about 3 years old, this is what we were doing in the garage. He would draw the line, one line, and I would cut to the line, then he'd draw another line. So this is what we do at home. We draw the line, aim for the line. It could be using a piece of pair of scissors, cutting a piece of cloth or paper. But when I ask people in a work setting, I said, instead of drawing the one line at home in the garage, do you ever draw two lines and say cut anywhere in between? And you should see the looks I get from people like, 2 lines anywhere in between? What a dumb way to cut a piece of wood. In which case I say, hold that thought, that's what we do at work, anywhere in between. So I asked a machinist once in class, I said, why at home do you aim for the line, the one line, and at work anywhere in between? And he literally said, because at home I cut wood and at work I cut metal. I said, well, who designs it at home? He did. Who bought the wood at home? He did. Who did final assembly? He did. Who designed it at work? Somebody else. So I point out to them is that the use of the line is what we do at home to improve fit. So it's not a new concept. And this is what I tell people with clients is, don't let anybody tell you that this is complicated. We've been doing it this way at home. And so, because at home, we're responsible for the pieces of the thing and how they come together, whereas in a work setting, we're either responsible for a piece or a final assembly, but rarely both. So at home, we understand that that thing we're working on is part of a bigger solution, whether it's manufacturing or planning a wedding or planning a vacation. So that's the difference between, and the idea is that focusing on the one line is what Dr. Taguchi is talking about. If the piece of wood is a little too long, then someone, me, has to take extra effort to get it to work. If it's too short, someone, me, has to do that. At work, it just means somebody else has to do that. That's how you get negative synergy. And this is, I just want to show you how this was used. Literally 30 years ago on this engine, a $500 million program when Rocketdyne was owned by Boeing, 18 feet tall. 3 of these engines flew in this vehicle, lifting the Air Force's, U.S. Air Force's heaviest, most expensive satellites. And so the main combustion chamber somewhere in there has a plate, kind of a plate, think of it as a round plate with holes, 628 holes around it. You know, there's an outer ring, a next ring, a next ring. And if you look at it sideways, you can see these holes. In each of these holes goes an injector, and through the injector flows liquid oxygen and liquid hydrogen. And the question becomes how to join the tubes to the plate. I don't know why. Oop, I'm going the wrong way, sorry. All right. So the easiest way to join these is to put a thin piece of what's known as braze foil in between the tube and the hole, and then at elevated temperatures, the braze foil melts, and that sticks the two of them together. And a friend at Rocketdyne years ago said, Bill, if people don't understand brazing, you could say it's like the cheese holding together 2 pieces of bread. So the ideal solution is to get the tubes brazed, with that cheese, the braised fillet. And in order to get the braised fillet where the braise flows out top and bottom like the cheese oozing out of the sandwich, that's the ideal way to do it. The challenge is anytime we ever made something like this, the best we ever got was 85% of the fillets in one cycle, which is like $15,000. The worst case is 50%. So we're looking at making one of these a week. And based on prior success, we'd be braising every one of them 3 times. You braise it the first time at one temperature. You braise it the next time another $15,000 at a lower temperature that you'll melt the first braise. All that extra work is part of how we do things. And so we weren't looking at going this way because it was just a mess. It would have cost too much, and they were looking at more expensive processes. Well, in the midst of all that, people I was working with started to focus on interactions. So traditionally, a machinist machines the holes to the absolute minimum, right? And the outer diameter of the tubes get made to the absolute maximum. And in that scenario, which of those two owns the gap between the tube and the hole? Answer, nobody. What's the ideal gap? We weren't thinking about the ideal gap. We're thinking about the parts in isolation. So experiments were run to find the ideal gap. Again, the ideal spacing between Jeroen and I. We agreed on the ideal gap and then took the distributions and aligned them to achieve the ideal gap. And that was done for 30 years. And it was done by suppliers managing those relationships. And we also showed, and I can't tell you how this same thinking not only improved assembly of the hardware, but also improved the fuel economy of the rocket engine, which is huge positive synergy. All right, and so this became a no-brainer. So instead of minding the part, which is traditional, we look at the parts in isolation. We did what the London Underground talks about, minding the gap. And they got to a point where programs could then choose, depending on the economics, should we mind the parts and bang it together, or is it worth the extra effort to get the ideal gap and not have to do that? Either one of them is a solution if you understand the options. And they decided to mind the gap for the life of the program. And this is the abstract at the beginning. So variation appears in how well the parts are integrated and how well the system performs. That's my story, and I'm sticking to it.
Thank you very much. Thank you, Will. Let's switch and see.
Yeah.
I don't see the people online.
Yeah.
Here are some questions. And then we go to a break. Are there any questions here in the room?
Well, again, the challenge is, what we're talking about is, in order to shift the focus from working separately to working together, we have to stop, shift the thinking from how did you do it, how did we do. Inherent in that is, not blaming, not looking at things in isolation, which is, on the one hand, giving out a prize to someone who we think did the most work, or someone who screwed up, which is looking at things in isolation. And where Dr. Deming's coming from is, if you have an environment of focusing on things in isolation, that leads to blame, that leads to people covering themselves, making the holes as small as possible, leaving the bowling ball in the doorway in order to get things done quickly. And that just accelerates negative synergy.
We'll share with you an example. If my colleagues or I, we go as consultants into a new company, the first question we always ask is, can you explain how your company looks like or what you're doing? And in 9 out of 10 times, the person we talk with, normally a director, has a classic organogram. That's the first thing they always present to us, with the director and managers and then team leaders and all functional, organized. Salespeople with salespeople, operators with operators, maintenance with maintenance, and so on and so forth. So that is an indication of their thinking. If the first thing you do is putting an organogram on the table, then I already get nervous. Then I think, all right, that's the way of thinking, meaning every department is on its own. And to get it even worse, we make KPIs per department. And to make it even worse, per operator, a KPI. And before we know, we are managing KPIs, we don't talk with each other, and we don't work together for the customer's purpose. We are all busy looking at numbers and divided departments in an organization. So you're not a team anymore. All the synergy is just gone. And that's
All the parts are good.
all the parts are good.
They don't fit.
Yeah, they just don't fit, but everybody meets the KPIs.
Yeah.
In the end, the business economics goes down, we make a loss, but everybody get a salary raise because you met your KPIs. Classic. Yeah.
Yeah.
All right, thank you for sharing. I think it's time for a break.